So we're not quite done yet with the FBD process yet, because one additional thing we would like to do is to also sample the fossil occurrence times. So this is to account for the fact that we never have perfect knowledge about the age of the fossil samples in our dataset. We have a minimum and a maximum age for each fossil, but we don't know anything more than that. So we can account for this uncertainty by simply representing the age of the fossil samples as an additional parameters that will be estimated alongside everything else in the inference. So this is what we're going to set up here. It is a little bit complicated piece of code, but we are going to do line by line. And of course, if you want a little bit more background on that, you can go back to the introduction as well, where it's explained in a bit more detail. Now the first line is to simply get a list of all the fossils that we have in our FBD tree. Now we're going to run through this list. This is what the for loop does, and for each fossil in the list we're going to set up an age, an uncertainty on the age for this fossil. Now the first thing to do is to get the age of the fossil from the FBD tree, so the currently estimated age of the fossil. And you can see this is a deterministic node, right? Because if you have your time tree, then of course all the tips in the tree, including the fossils, have a specific age. So this is completely deterministic. Then we're going to grab the minimum age and the maximum age of each fossil. And so this is given by our data, right? If you remember, we loaded a data table earlier that contained the minimum and the maximum age for all the species of bears we have, and so including the extinct species. And once we have that, we are going to set up a stochastic node that will have a uniform distribution between this number, so the current age of the fossil minus the maximum age of the fossil, and the current age of the fossil minus the minimum age of the fossil. And the way that this works is that if the current age of the fossil, t of I, is compatible with the interval, then this is going to be a negative number, right? Because the current age is lower than the maximum bound. And similarly, if the current age of the fossil is compatible with the interval, then this is going to be a positive number, because the minimum age of the fossil has to be lower than the current age of the fossil. So if we have a good age for our fossil, an age that is within our interval, then this distribution is going to contain 0. And so we're going to make sure that this stochastic variable is set to 0. And so ultimately what this whole thing does is set the likelihood of the fossil to 1 if the current age of the fossil is compatible with the interval, and it's going to set the likelihood to 0 if the current age of the fossil is not compatible with the interval. So we are setting up essentially a constraint of the fossil age based on the intervals that are contained in our data. And last but not least, since we want to estimate the ages of the fossil, we have again to set up moves on those fossil ages, and RefBase provides you with a nice move that allows to move all the fossil ages without having to specify it for each separate fossil individually. And so this takes the tree, the origin time, and then of course, as we said before, for all moves you need a weight parameter.